Hi, welcome to session 5 of this machine learning for beginners. So today we are going to talk about an algorithm called random forest, and we will use this for classification. If you remember, we said that primarily there are two kinds of things we predict. Either we predict some kind of a number, which is analog in nature, meaning continuous. For example, if the stock prices yesterday was $101, what is it going to be next week? So maybe $105. So that is some kind of a prediction which is continuous in nature. The other one is classification, meaning is this a red ball or is this a blue ball? So put them into their respective buckets. So random forest classifier is an algorithm that is used for such classifications. Let's learn by example. So let's take a small digression and understand flowers. I will quickly tell you why I'm talking about flowers. So let's say I have a flower and this is called petal. I'm not that good in biology, by the way, so bear with me if my pronunciations are wrong. And in between you would have seen these green things, and these things are called sepal. Now what we want to do is, based on the dimensions of petal and sepal, dimension means height and width for both of them, we want to predict what is the species of this flower, and it can fall in one or more categories. So category 0, category 1 or category 2. This is a classification exercise. Given the petal dimensions and the sepal dimensions, how can I predict what species this flower belongs to? So how do I do this? Using random forest. Let's take this example. So I have sepal, width, sepal height. Let me make it smaller. So I have sepal width, sepal height, petal width, petal height, and I have to predict the species. So let's say these things are in centimeters. So 5, 3, 2, 1, and the species is of type 0. Then again, let's say it is 4, 3.2, 2.4, 0.8, and this is of type 1, so on and so forth. Remember, we said we always take input data and break them down into train and test data. So with this data set, I will take a subset and create a training data set, train my model, and then let's say 20% of this is kept as test, and then I will see if my predictions are correct or not. If we didn't have random forest, what is it that we would probably do? We will write perhaps an if then else statement, which is nothing but a rules engine that could say if sepal width is equal to 5 and sepal height is equal to 3 and petal width is equal to 2 and petal height is equal to 1, then species is equal to 0. Else if and so on and so forth. This will continue. This is a tedious exercise. Random forest is just a enhanced, refined version of a rules engine. So wherever you have rules engine and you want to add machine learning to it, maybe the easiest thing to start off is to see if random forest can replace it. So wherever there is rules engine, we probably be able to start with random forest. So the way it works is a normal rules engine would be like this: sepal, let's say again, remember this, sepal width 5, then I will check sepal height 3, then I will check petal width 2, and then I will check petal height as 1, and therefore the species is 0. Again, sepal width 4, sepal height 3.2, petal width as 2.4, and then petal height as 0.8, and then my species is equal to 1. So this is how I build the tree. In a generic case, what random forest does is it takes and it builds small trees. So it will take this one, it takes a subset, and then it probably takes the another one. So it will say, let's say I will start with sepal width if it is 5 and petal width if it is 2. I will say the species belongs to group 0. This is one tree. Or another way, sepal width is 4 and then petal width is, how much is this? This is 2.4. So I'll say 2.4. If that is the case, my species is 1. Then I will build another tree, but this time I will build using sepal height and petal height. So I'll say sepal height as the first one is 3 and then petal height is 1. Then my species is equal to 0. For the second one, I'll say sepal height is 3.2, petal height is 0.8, and my sepal width, sepal species is equal to group 1. And this way we will build many different small trees, and that is where the name forest comes in. So we have a bunch of trees making it a forest, and the reason it is called random is the rows and these columns are chosen randomly to build the tree. So if every time we input now these 4 variables, sepal width, sepal height, petal width, petal height, it will run through each of these trees and produce multiple outputs, right? Because each tree produces one output. So it is here, some tree will produce here, some tree. So species, somebody will say 0, somebody will say species is 1, and so on and so forth. It will take what is the answer? The answer is wherever there is a maximum occurrence. So if there were 10 such predictions and 7 of them says the species is 1, then the answer would be species is equal to 1. That's what random forest does. Now, let's take, or rather before I take an example, let's understand a couple of more things, terminologies. So, when you have input parameters, let's say A, B, and C, and you're trying to predict the output parameter Y, these are called features. And this one is called label. So, we use 2 or more features ideally to predict the single label in random forest. Second, so that's one, so that's one terminology. Second, remember, in random forest, what I have seen is sometimes the features could be of different dimensions. So, for example, one thing could be representing color and the other thing could be representing height. Since in machine learning, remember, everything is a number. So red, blue, green, all are, if they are categorized, so 0 means red, 1 means blue, 2 means green, and so on and so forth. And height could be in feet. So it could say 6 feet, 5.5 feet, and then 5.8 feet, and so on and so forth. These numbers, if they are not attached with dimensions, which is what happens, generally I have seen that the feature with higher values is given higher preference, meaning the output, what is the value of the output, is heavily influenced by features that have higher values, whereas that is not correct because these two things represents completely different things. So in those cases we do something called scaling. The easiest scaling is min max scale. What it does is it takes all of these features and puts them into a range between 0 and 1. For example, let's say red was 0, blue is 1, and green is 2. So we could say that red is 0, blue is at 50%, which is 0.5, and green is 100%, which is 1. Similarly, height between 6 and 5.5, that is the range. This can be converted into a value 0 to 1. Therefore, the new table for features could look like color and height could be like this: 0, 0.5, 1, and then this could be 1, 0, 0.8, and so on and so forth. Now both of these columns are normalized, and therefore generally none of them, because of the higher values, will get higher weight, and that's something you should check when you are doing your predictions. The last thing, terminology or important thing that we want to understand is how do we know that our quality of prediction is good. For that we create something called confusion matrix. It is basically a table around 2 dimensions. So let's say I had to predict the species of the flower, right? And the species belonged in 3 categories: category A, category B, and category C. So this one would be a table with 9 cells: CA, CB, CC. Again CA, CB, CC. This one can represent, let's say, the predicted values or the predictions, and this one can represent the actual values. Remember, we have train and test. So these are my test values. Now, after I have built my model using the training data, I will go ahead and run it against the test data and come and create a confusion matrix of what I have predicted. And ideally, I should have, let's say I have 30 values for testing, and each one were around these categories A, B, and C were equally divided. So I should see 10, 10, 10, 0, 0, 0, 0, 0, 0 here. What does it mean? It means there were 10 category A species and they were correctly predicted as category A. There were 10 category B species and they were correctly predicted as category B. And then there were 10 category C species and they were correctly predicted as category C. If I have errors, I might see numbers like 9 here and 1 here. This means there were category C 1 plus 9, 10 category C species. But of those 10, only 9 were correctly identified as category C, 1 was wrongly identified as category B. So that's what confusion matrix tells me. Fair enough. Let's recap. So random forest classification is nothing but an advanced version of rule engine, where we take a set of input features and then try to predict an output. An output is basically called label, and it is generally things like true, false, red, blue, green. It's a category demonstrator. And the way it works is it creates multiple small trees, and these trees are created randomly by selecting rows randomly as well as the columns randomly, and these are called, that's why it is called rather random forest, made up of multiple trees, and these trees are used as estimators. These are the ones that estimate, and when we get all the estimates, a simple voting is used to pick the estimate that was created by or predicted by the maximum number of estimators. Then remember, with the third thing we learned is feature importance, where min max scaling was used to ensure that, if I have one feature which is demonstrated as in kgs, let's say 1, 2 and 3 kgs, whereas the other feature is using centimeters like 20 and 30 and 40 centimeters, because these numbers are higher than these numbers, as I said before, sometimes this becomes the dominant factor in prediction. So it perhaps makes good sense, always test your data before doing this, by the way, to convert them into a min max range value, and that could mean 1 is minimum, so it is 0, then 2 is in the middle, so it is 0.5, and 3 is maximum, so it's like 1, and similarly these values, so 0.5 and 1. Now both of them are on the same scale, and then none of them will get an undue advantage in the final prediction. And lastly, how do I know how my prediction is? By looking at the confusion matrix. So that's fairly what random forest is. Now let's go and do a sample. Okay, so let's try and write a piece of code that will use random forest prediction. And remember what I said as an example. We will take the iris dataset. Um, so from sklearn dot datasets import load iris. Then we need the random forest classifier. So from sklearn dot ensemble import random forest classifier. I think it's capital C, yes. And we would need to split our data in training and testing. So from sklearn, I believe it is in model selection, import train test split. Okay. Uh, we want to try out min-max scaling from, I don't remember, but we'll see sklearn dot pre-processing import min-max scaler. If we get an error, we will see from, and then we need to check the confusion matrix. So from sklearn dot metrics import confusion matrix. Okay, and then of course import pandas as pd, and perfect. Okay. Min max killer. What is the name? Is it capital S? Yep. Okay. So now let's load the iris dataset as load, and I explained that this is about sepal, petal, and so on and so forth. And from this, let's create the data frame first. So pd, so that it's easy to look at. Frame and iris dot underscore dataset dot data. I have used this before, so I know it's data, and then the columns are iris dot feature names. Okay, so df dot head. Let's see, did we do this right? Iris dot data, iris dot iris iri. Okay, iris data set. Sorry about that. Okay, so see, sepal in centimeter width, sepal width in centimeter, petal length, and petal width. These are all in centimeters. What is missing here is the classification. So these are my features. There are 4 features, and based on these features, I will determine what is my species. So the species is also there in the iris data set. So let me add a new column. Before that, let me extract PECIES. It's array for S in iris data set dot target. How I know this? I've used this before, this data set before, so I know it. All the species are saved in the target array as numbers. Just for the sake of readability, I will change these numbers into names. So I will say specis dot append. The names are stored in a category array. So is under data set target names, and then I can simply, so this target will tell me the in the category value 0, 1, 2, and so on and so forth. And target names are the categories. So it will say category A in index 0, category B in index 1, so on and so forth. So that way I can actually get the species names and then add to my data frame this column. Now let's see if I am getting, yes. So I get the name of this species, Setosa. I'm not a biology student, so if this name is wrong, fine, you understand what I mean. So now I have the 4 features and I have my label. This label is one or more species name. Now what I need to do is I will have to build a model where based on the sepal and petal dimensions, I should be able to predict the species. So for that, I need to break my data into train and test. So I will do X train and X test, then Y train, Y test is equal to train test split, and I need to split the X data, which is features. So X means features and Y means labels. So I need from my data frame all the features. So iris dataset dot feature names. So this is nothing but these names: sepal, width, height, petal, width, height. And for the y axis I need the species. So I will say this data frame, this species contains, and then test size, the size. So 80% train, 20% test. So test size is 20, and that should give me, just let's just see if I dot head. Yeah, so I have split my data into training and testing. The training data is the 4 input features, and the label is the species, this Setosa name, right? So there are one or more names perhaps in that list. So I have this. Now let me build the classifier. So CLF is equal to random forest classifier, and remember the number of trees, decision trees, how many we want. So that's called n estimator. So I will, let's say 100. I don't know, I'm just putting a number right now. We will see how we can optimize this. That's an optimization parameter. So CLF dot fit, I want to give X train and Y train. This is my training. So X, this is the 4 features, the sepal and petal width and height, and Y train is the name of the species. Now I will go and predict. So Y predicted using this model CLF dot predict, and I have to give as input X underscore test. So now I have the predicted data. Let me see. So I have some prediction of the data. How do I know that this prediction is accurate? Then I have to compare Y predicted with this Y test. Let's just print what was Y test. So, okay, one second. Y predicted, Y test. So I can look at this, and this one is versicolor virginica or virginissa. I don't know, but yeah, the spelling is same. So they look same, but there is a better way of doing it, as I said, is to create a confusion matrix. So I will create uh, a confusion matrix. So confusion matrix, if I use this one, and I have to say y test, this is the test parameter against how I predicted. So y predicted. If you see, let's see how many, what was the length of y predicted, how many variables were there. Let's just see. Print length of y predicted. So I had 30 values to predict. Now if you see, as I said, left hand side are the 3. So versicolor, virginica and setosa. These are the 3 categories of species. So on the left hand side on rows, it says the 3 category of species, and on top in the column again those 3 categories, but this is predicted, and left side is actual. So it said there were 10 versicolor species actual, and those 10 were predicted correctly. This 0 and 0 everywhere you see says nothing was incorrectly predicted. Ideally, your confusion matrix, the diagonal should have values and all of them should be 0. Here we have a problem. This one got predicted wrongly. It means it was one species, but we actually predicted wrong. And that's fairly good. Now, if you want to see how I can optimize this, so I will reduce the number of estimators, which means my number of decision trees, and let's see if it impacts our decision. So right now only one value was incorrect. We still have one value only. So now if I just have one, we have multiple incorrect values. So 1, 2, 3, 4, 5, 4 values are incorrect. So this is one way of optimizing it. Now with estimators, 50 or even 20 estimators, because the data size is fairly small, I still get the same result. So I didn't need 100 estimators. One more thing I can optimize is what kind of weightage are my features getting. So let's see, from this classifier, feature underscore importances underscore, I think that's what it is. Yeah. So if you see the first one, sepal length, sepal width, petal length and petal width, these are 4 features. So sepal length was 12%, given 12% importance. Sepal width was given 2.5%. Petal length was given 40 and petal width was given approximately 45, 44.90. That seems to tell me that the petal values have been given more importance than the sepal values in general. So can I first do a min-max scaling of this value and see if I can improve the prediction. So let's do this here. So after I have done my data frame, I really want to create a data frame that has actually the sepal width height, petal width height values, min max scale. So min max scalar is equal to min max. This time I'll not do this mistake. Okay, and then I'll say min max scalar dot fit this data frame, all the columns are iris and dataset dot feature names. I just want to show you what it contains. So if I say iris dataset feature underscore names, so this is just the names of the features, which is the column name in our data frame. So I'm just using that. So I'm going to fit feature names and then using min max scalar. Now min max, so if once I've done the fitting, now I have to convert the data frame values into min max values. So data frame for all these columns is equal to min max scalar dot transform these values. So replace the feature columns with the transform values. Let's see what is the new transform value. Perfect. So if you see, there are now values between 0 and 1, and with these values, now if I go and split train test and then create my classifier, let's say if I am able to, my results are still the same, but importance, yeah, so 7%, 18%, 50, not too high, but it demonstrates the concept. In some cases you will see changing the feature values and scaling them will start to show you improvement. So that's pretty much what random forest was. Let me know in your comments below if you find a mistake or you want to know more. Thank you. Have a nice day. Bye bye.